Okay, today we're talking about Chapter 1, Section 6, the product and quotient rule. Alrighty, so from the top, one moment. Alrighty, so some functions are easily viewed as product of two other functions. For example, if we have some f of x is equal to x squared plus 3x, the quantity of that, times the square root of x, uh, is the product of f of x equal to x squared plus 3x, and g of x equal to square root of x. However, as a rule, the derivative of a product is not the product of the derivative. So let's underline that, because that is almost as important as Theorem 7. So again, as a rule, the derivative of a product is not the product of the derivatives, right? So what's happening is we're not. It's not as simple and cut and dry as we did with addition and subtraction, right? We derived or took the derivative of each individual term. In this particular case, that is not the case. Okay, so if we have some function and it's comprised of two smaller functions, right? F of x and g of x, then the derivative of that, again, f prime of x means the derivative, or remember d dx, that notation meaning we take the derivative of this, then the derivative is going to be the function times the derivative of g of x. So f of x times the derivative of g of x plus g of x times the derivative of f of x. Okay? The derivative of a product is the first factor times the derivative of the second factor plus the second factor times the derivative. That's kind of what I just said. Yeah, no. All right. So let's do an example of this to really drive this point home. And what I'm going to do is this is certainly one of those times where the color coordination really comes into play here. Okay, so we're gonna do number one first. Um, so it reads, find the derivative of, and then it's all in the parentheses there, x to the fourth power minus 2x cubed minus 7, here I'm right here, minus 7 times the quantity of 3x squared minus 5x. So in order to find the derivative of that, okay, so we're just going to do this the very long way. We're going to take this whole page up to do A. Okay, so we're going to first denote f of x. All right, we're just staying in line here. We're just going to say f of x is the first equation there. Um, Actually, I wanted to color coordinate this. Let's do it in blue. To A. Okay, so f of x is x to the fourth minus 2x cubed minus 7. All right, so let's go ahead and just take the derivative of that. So the derivative is going to be f prime of x, okay, and the derivative is just going to be, we can do these in our head, so 4x cubed minus 6x squared, and then 7 doesn't have a derivative, right? So that's that, and then we're going to do g, we'll say g of x is 3x squared minus 5x, and therefore g prime of x is going to be 6x minus 5. Okay, so I put all that out, and recall that the derivative of this particular function, okay, is going to be, it's going to be in the form of first times the derivative of the second plus the second times the derivative of the first. Okay, and realistically, we could have probably used a lot of the colors. And I'm gonna back up just a tad, and I am gonna use all the colors because I feel like it's kind of needed for this situation to really drive the point home, just to kind of see where things go. Okay, so we'll fix this up. We'll say f prime of x, just basically writing what I just had. And g prime of x, 6x minus 5. There we go. Okay. So again, all I did was just simply rewrite what I just had. So again, going back to our product rule here, we had the first f of x times the derivative of the second, so g prime of x, plus the second, which was g of x, times the derivative of the first, which is f prime of x. Okay, so that's the format that we are going to that we're going to follow. So let's go ahead and write that. So f of x is x to the fourth minus 2x cubed minus 7 times g prime of x. Let's put this in parentheses here. I'm pretty sure it's, oh yeah, oh, good. I knew it said do not simplify because it'll get pretty ugly pretty fast. But it says do not simplify. So with f of x and then g prime of x we said was 6x minus 5. I said it would get pretty ugly pretty fast because notice how we would have to do the distributive property here on all of them. It would get very ugly, but that's fine. We don't have to do that. Anyways, g of x was 3x squared minus 5x, and then multiplied by f prime of x, which was 4x cubed minus 6x squared. Okay, and I believe that'll do it. All right, so that was A. So let's do B now. Really glad that the textbook threw us a bone here and made us and asked us to not to simplify. All right, so B, we're yeah, I guess I don't know. We'll go ahead and do the color coordination like we did last time. What did we do? We did blue, red, yellow, green. Blue, red, yellow, green. So f of x is, we're just going to denote it as, excuse me, x squared plus 4x minus 11 f prime of, let's fix that up, f prime of x is going to be 2x plus 4. Did I do yellow? I forget. Okay, good, yellow. And then g of x is 7x cubed minus, and I'm going to go ahead and write this with a rational exponent because it makes the finding the derivative that much easier, right? So the square root of x is simply going to be x to the 1/2, right? And then g prime of x, well, that's going to be 21x squared, and then the derivative of x to the 1/2, if you recall, is going to be, so it's going to be minus 1/2, and I messed up. Oh yeah, we'll put that in the denominator. Well, no, we don't. We'll just keep it as a negative exponent. I'm pretty sure textbook does as well. Because we are not simplifying. Minus 1/2 x to the negative 1/2. Okay, so I'm not gonna write this again, I'm just gonna follow off of, you know, first times derivative of the second plus the second times the derivative of the first. So we say the first times the derivative of the second plus the second, oh, am I going to run out of room? We're going to try not to. Plus the second times the derivative of the first. Okay, so there's that. And, well, that concludes example 1. Example 2. This is an interesting way to go about things because you can kind of just see, I mean, it's interesting in a way, I guess, but you can just kind of see that there are multiple ways to go about finding the derivative here. For this particular problem, it reads, find f prime of x 2 ways. First, by multiplying the two binomials and differentiating the product, and then by using the product rule. Okay, so first one wants us to take the two binomials, multiply them together, and then differentiate the product. So let's go ahead and do that. So we've got 2x plus 1, x squared minus 3. Okay, so again, we do we just we FOIL, right? We know how to FOIL. So we FOIL. So we end up with 2x cubed minus 6x plus x squared minus 3. Right? And let's go ahead and rewrite this being in in descending order. Sorry, we have x cubed here, so we're just going to swap these two. Okay, we're going to put the x squared first, just to make this a little bit nicer. So plus x squared minus 6x. Plus x squared minus 6x. Okay. All right, well, let's take the derivative of that. So the derivative, so again, we're going to put right d. Well, it does have a name f of x, but we're still going to write d dx, which again just means take the derivative of 2x cubed plus x squared minus 6x minus 3. Again, just means take the derivative. We also know that this could also be written as f prime of x, right? We also know that, but we're just going to say take the derivative of it, right? And the derivative of it is going to be, I think we can put it over here. Okay, so 2x squared, I'm sorry, 2x cubed, that's going to be 6x squared, right, plus 2x, and then minus 6. Okay, so that's taking the binomials, multiplying the binomials, and then taking the derivative of the binomials. All right, next it wants us to do our product rule. Okay, so the product rule. Okay, so we're just going to do this in one color now. We've kind of padded out how to do, all the color coordination and stuff. And not only that, but I mean, you as a student, I mean, I will say that there are some students that do have different colored pencils, but for many of you, you generally have that graphite color, right? So we're just going to roll with this. So we're going to say f of x. Actually, you know what? Since I do have the tools, I might as well, right? Blue, red, yellow, green. Blue, red, yellow, green. I might as well. So f of x is 2x plus 1. F prime of x is just simply 2. Well, that's easy. Yellow, g of x is equal to x squared minus 3 and g prime of x is equal to 2x. Okay, well, first times derivative of the second, so, oh, it does want us to simplify though. Okay, so we are going to simplify. So first times derivative of the second, so we've got a 2x plus 1 times the derivative of the second, which is going to be a 2x, plus the second, x squared minus 3 times the derivative of the first, which is a 2. Okay. Yeah, we're good. And now let's just simplify from here. Not simplify, but kind of distribute here. So we're distributing backwards. We have a 4x squared plus 2x, and distribute here. We have a 2x squared minus 6 plus 2x squared minus 6. And then if we clean that up, the x squareds, they combine to get 6x squared plus 2x minus 6. And I'm pretty sure that's what we had here. Yep, 6x squared plus 2x minus 6 and 6x squared plus 2x minus 6. So what did this exercise prove to us? Well, it proved to us that, okay, it's on the next page. It proved to us that we see that both methods give the same result. Shocker, right? And so as a student, you're thinking, okay, so if they both give the same results, how do I know which one to use? Well, to be completely honest with you, it really just depends, and you just really have to fully understand the content to really decipher which one you think is better. Okay, and here's how I do it. In this particular case, we have two nice, pretty binomials, right? Let's see, there's binomial here, binomial here. It takes all of about 7 seconds to FOIL that and combine like terms. And then once I get to that, then I can, on this page, once I get to this, then I can just simply differentiate that. And again, I can just differentiate that in my head, right? And, I'm sure you can either now or next week. Once you really practice how to differentiate, you'll be able to differentiate pretty quickly. However, on this example, I am in no hurry. This one or A, I think. Yeah, I am in no hurry to uh, factor here, combine like I don't know. It might be as quick. I don't know. But realistically, it's your own discretion. How do you want to go about doing things, and that's that. Okay. Next up, we have the quotient rule. So if we had the product rule, right, being multiplication, well, then the quotient rule would be division. And furthermore, if the product rule was okay, then the quotient rule is going to be not okay, right? Because we all know division just sucks, right? So just going on to a theorem, Thermate the quotient rule, right? So if we have some big f of x that's equal to little f of x over g of x, then f prime of x, okay, then the derivative of that is going to be this, okay? Now, this might be a little harder to remember than the product rule, okay? And again, just to recap, let's see if I can let me type this out. Okay, that's not the color. We just make it white. Let's make it a little larger. It's not large at all. I don't do this often. How in the world am I going to make this larger? Okay, let's try this again. Do we change the color back? Okay, white. The first times the I lost my mind. Derivative of the second. All right, let's see if we can't make this a little bit larger. up. All right, so what I'm doing here is just kind of, it's not necessarily a mnemonic device, but it's what I use, right? So the first times derivative of the second plus the second times the derivative of the first. Okay, so this is what there's got to be a way to make this larger. Oh, well, we can center it. That's what I want. That's good. It's a good button to hit. There we go. There we go. Okay, so let's make it 20. There we go. Okay, so this is what we need to remember as far as the product rule. And again, I'm just kind of harping on this because you're going to need what I'm about to tell you for the quotient rule. Okay, so that is what you just kind of say in your head whenever you do the product rule. The first times the derivative of the second plus the second times the derivative of the first. Okay, did I spell derivative? I feel like I spelled derivative. Yeah, okay. I don't know. It's been a long week. All right. So with that said, let's have something for the quotient rule. Okay, so the quotient rule, what we're going to do is go ahead and make this 20. Go ahead and make this white. And we're going to go ahead and center it. Okay. It's low. Let's make this, put this all over here. Low D high minus high D low all over low squared. Okay. Now, let's just kind of examine this real quick, but in case you are like, what the heck we just look at here? Okay. So here we go. Low D high. That means so again we're looking at a quotient. There's a function on the top and a function on the bottom. Low D high means low times the derivative of the high, and that's what we have here. Low, which is g of x, times the derivative of the high, minus, that's the minus here, high d low, minus the high times the derivative of the low, which we have here, high times the derivative of the low, and all that over low squared. Okay, and so it it comes out low d high minus high d low, kind of like like high d high hello, but yeah, so low d high minus high d low all over low squared. Right, this is what I used when I was going through this, and this is what I use many years later, and hopefully it serves you well. Okay, but enough talking about it. Let's see if we can't put that to work. So kind of the same procedure here, right? We're gonna let f of x be in the numerator and g of x be in the denominator. And I never forget the color. I do blue, red, yellow, green. Blue, red, yellow, green, Sherman. Okay, so blue is equal to 1 plus x squared. The derivative of that is just going to be 2x. G of x is x cubed plus 1. Kind of can't see it, but that's fine. We know what it is. G prime of x is going to be equal to 3x squared. Okay. So if we follow along with what we just said, and let's actually go back and maybe we can snip this real fast. No, okay, hang on. No, I don't want to snip it. I want to copy it. Can I copy this? As you can tell, I don't really type. I usually write on here. Oh shoot. Okay. Okay, we'll do this. I wonder if I can do this. We're going to add it to the library. And don't know how to do it from there. All right, well, we're just going to have to rewrite it. Right, so since this is just a small pane, we're going to not do this again. next one. Okay, so it's high d low minus low d high all over low squared. I'm pretty sure that's what I put. Exactly right? I just want to make sure I didn't put in another word. Okay. So here we go. It becomes high d low. So high is going to be the f of x. So it's going to be 1 plus x squared. High, and then d low. So the derivative of the low is going to be 3x squared minus low d high. So the low is going to be x cubed plus 1 minus low d high. So low, and then the d of the high, the derivative of the high one, is 2x. Okay, and then that all over low squared, which low squared is going to be x cubed plus 1 squared. And let's see, it doesn't necessarily, okay, so it does want us to kind of fix this up. But realistically, I'm not going to. I'm going to keep everything on this one page because there's no point in distributing. So instead what I'm just going to do is just kind of clean it up right here. Okay. So this is just a cleanup process. There we go. Hang on a second. High d of the low. Oh no, Sherman, you did mess up. Oh no. Okay, so I did mess up. Dadgummit. That sucks. I actually had that backwards. Did I? Low d high. No, I didn't. I didn't have that backwards. I had this backwards. Sherman. Okay, good. I know I didn't mess that up. So let's actually erase this and try that again. It's a good thing I actually looked. I'd hate to send you on your way like this. Let's try this. Yeah, maybe I should have looked a little bit harder on the on the previous page because I did start with low d high there. So let's try that one more time. Sorry about that. So low d high. Here we go. I got the low squared though, right? So low d high, we've got x cubed plus 1 d of the high, so the derivative of the high is 2x, and then minus high d low, which is 1 minus x squared. And the derivative of the low is 3x squared, and then it's all over low squared, which is x cubed plus 1 squared. Okay. All right, sorry about that. Got a little confused there. It happens. All right, so example 4, we're going to let g, so first by using the quotient rule and simplify, and then by first simplify. Okay, so kind of the same deal we did with example 2. We're going to do the quotient rule, and then we're also going to do, we're going to simplify it. Okay. All right, so same deal. We're just going to denote, so we've got f of x is equal to x squared plus 9. I'm sorry, x squared minus 9. F prime of x is equal to 2x. G of x is equal to simply a 1. I'm sorry, not 1. That's the derivative. X minus 3. And then g prime of x is equal to 1. Okay. All right. So low d high minus high d low. Remember that. All right. Don't be like me and do it backwards. All right. Low d high. So real quickly. Um, well, no. You as a student can configure some of these mnemonic devices, and this isn't even a mnemonic device, but you as a student can figure some of these things out on your own, I guess. But just try to follow along with this and make sure low goes first, right? So it's a good thing that I made a mistake, because mistakes happen. Let's go ahead and just take the time and write that out again, anyways. I'm not in a hurry. Okay, here we go. So low d high. So we have low, which is x minus 3, minus, or I'm sorry, times the derivative of the high, which is 2x, minus high d low, which is high x squared minus 9, and then d low, which is simply a 1. A little redundant, but we're going to put that anyways. And that is all over low squared, which is x minus 3 squared. Okay, now this is something that we're going to clean up a tad, because since we're actually getting somewhere here. Oh no, okay. Well, can't do that. All right, so I wonder if I can fit that. Okay, so we end up with a 2x squared minus 6x. So 2x squared. I'm not gonna be able to fit this. Okay, so I done messed up. I can't pull this over unless I pull the wording as well. But I guess I can put the wording over. No, here's what we'll do. We'll just straight up go to a new page. Well, lectures sure are color. I mean, I feel like they're better when they're colorful. That's just my opinion. All right, so let's do the arithmetic here now. We've got a 2x squared minus 6x, and then minus, right? Okay, well, again, looks like the 1 just simply distributes through there, right? So we have a minus x squared minus 9, and before we even move on, let's just go ahead and distribute that negative sign through, right? So let's just go ahead and distribute the negative sign through. We're going to end up with a minus x squared plus 9, and that's all over x minus 3 squared. It's already in factored form. We're going to leave it as so, because I'm pretty sure we're going to be doing some sort of canceling here, I think, anyways. Okay, so let's combine these like terms. We have 2x squared minus x squared, so that's just going to be x squared minus 6x plus 9 all over x minus 3. And this gets a new page. All right, and again, all those factoring things that you learned in your previous courses, and you're like, ugh, this is awful. Why do I have to do this? Well, we're here. This is why we have to do this. So we end up with x squared minus 6x plus 9. So that factors into, it looks like x minus, yeah, x minus 3. Okay, so, oh, hang on a second. Squared. Forgot to put the squared there. Okay. So my numerator becomes x minus 3 times x minus 3, or x minus 3 squared. My denominator is x minus 3 squared. Well, anything over itself is just simply equal to 1. Okay. So so that's my derivative of this is just simply 1. All right, and then provided that, and this is very important, x is not equal to a positive 3. Okay, we have to say that because that is in my denominator, right? I cannot have a 3 in my denominator, or otherwise it would be undefined. Right. Now let's do the second way that the text wanted us to go about doing this, and that was simplifying it first. Okay, so let's simplify this before. That was a horrible snipping job. So let's simplify this before we get to the uh, differentiating part. Okay. So simplifying, we got g of x is equal to. All right, so x squared minus 9. We know that's a difference of squares, right? So we're going to move that. Let's move down just a tad. So g of x. We know that the numerator is a difference of squares. We know that it is an x plus 3, x minus 3, all over x minus 3. We know that the x minus 3's cancel, right? And then we are left with simply an x plus 3. Okay. Well, that's g of x. If I take the derivative of that, right? So g prime of x, and again, g of x is this. Well, then we see that that derivative is just simply 1. And same thing, provided that x is not equal to a positive, I'm sorry, a negative 3. Was it a negative 3? No, yeah, it's a positive 3 because we're looking at my denominator here. Okay, and so that was pretty simple. That was way simpler actually, right? Um, that's just the way it is, just way simpler. Yeah, okay. It's just calculator work. All right, so the application of the quotient rule. This kind of is an okay application of it, but I want to kind of shift gears on this particular example, um, real quickly. And it's actually just going to get its own page because, to be honest with you, it's nothing that we haven't seen or done before. But like I said, there is one thing that I do want to point out about this particular example. And while I'm at it, I'll just go ahead and do the section summary. Okay, so really quickly, I have this down on my other computer, so we're gonna put this on this computer real quick. Um, Desmos. Okay, so it was negative 80. I meant to do this before lecture. Sorry, not a big deal. Plus. Okay, I think that's it. All right, so let's go ahead and look at this example real quick. All right, so I said it's okay. So the application of it. Here we go. The application of our quotient rule. Um, we're just talking about total cost and stuff. So the definition we have C of x. C of x just means average cost. Okay. R of x is R stands for revenue, and P is just simply the profit. Okay. And notice in each one of them, you have the cost function over x over what you are producing, I suppose. Revenue R of x over the x, and P of x the profit over x. Okay. So hopefully it's not abundantly difficult to memorize. Not only that, but on your test, you'll have the bump in the right direction. You don't think there's many brain cells that need to be expended to remember that. All right. So this example, business. So Paulson's greenhouse finds that the cost in dollars of growing X hundred geraniums is modeled by this. Okay, this is her cost function, which, by the way, I probably said this already in this course, but these functions don't just pop out of nowhere. These functions are created largely by something that you take after calculus 3, and that's called differential equations. And that's what comes up with these equations. Most of them. I don't know about these, but a lot of them, right? But this is the cost function, and this is the revenue function. Okay, and it didn't necessarily tell you on here what the profit is. All right, but you can think of the profit, right? If you have cost, and if you have um, we'll put this down here. If you have cost and you have revenue, okay, the cost is how much it costs for you to do something, right? Well, you can think of profit as, well, you would think of it as revenue minus the cost, right? And that should make sense, right? It doesn't necessarily say it here because it just says profit, right? Whatever. But the profit is how much money do you make minus your overhead, right? Minus however much your bills are, your employees, things like that. So it doesn't say it there, but I mean that's just one of those things that you just kind of think about it and you say, okay, that does make sense. Okay, but anyways, so we have our cost function here, our revenue function here. So A wants us to find the average cost, average revenue, and average profit when 300 geraniums are sold. So all I have to do here is just simply plug in 300, all right, into these equations. But real quickly, cost in dollars of growing X hundred geraniums. So X is simply is 100. Okay, so in these equations, you're just going to plug in the number 3. Okay, and again, this is intro to college algebra stuff right here, right? Well, all we're doing is plugging in 300 and then just slapping away. I mean, you just put it into your calculator and you just get it, right? So you plug in 3, again, X is in hundreds. So you plug in 3, the cost to produce 300 geraniums is $110 per geranium. All right. The revenue of selling these is $91. The profit, again, is going to be just simply, and we see it here, revenue minus the cost. The profit is negative $18.50. That sounds horrible. We're selling at a loss. We're operating at a loss here, and that's kind of the point I want to drive home whenever we get to the Desmos portion of this. Okay, so A is just college algebra. You just simply plug it in. Now B says or asks the rate of change at which the rate at which the average profit is changing when 300 dreams are grown and sold. So now what you do is you take the derivative of the profit. You take the derivative of this equation right here. Okay, and again it's well it's low D high minus high D low, right? So once you do all that arithmetic involved here, you end up with 11.2. Okay, and again, this is just the work that we did on the previous two examples. It's just low D high minus high D low. Okay, so once we get to that, we get to our solution. Sorry, I hand waved a little bit through that, but my main point I want to show here is I thought it was pretty interesting, a pretty interesting example, and I don't think it goes any further into the example. No, I think it's a pretty interesting example because we see here at 300 geraniums, we're operating at a loss. But also at 300 geraniums, the instantaneous rate of change really, we are growing in profit by $11.20. So what this is kind of saying is there is going to be a point in which we do end up selling geraniums to make a profit because if we are changing at $11.20, right? If our profit is increasing, right, for each additional 100 geraniums sold, then we should be operating a profit soon-ish, right? And that's where a lot of calculus just kind of comes from, is just looking at graphs and reading graphs. And that's what we're going to look at right here, is right here. Okay, so if you recall, the problem was at 3, right? So at three geraniums, right here, close to 3. If you recall, we said that hey, we're operating at a loss of negative $18.50. Okay, or at 300, sorry, 300. All right. Well, when we get to when we start selling 740-ish, I don't know where we're at. Yeah. So when we start selling 741 geraniums, we'll have broken even. Okay. And even that, check this out. You see how it goes? You see how the graph goes up? Let's see, here we go. Goes up and then just kind of dips a little bit, right? Kind of dips a little bit, right? Well, there is a point right in here, it looks like, where we're going to be making maximum amount of profit. Okay, so like if we 50, it's in the hundreds, right? So 5,000, 10,000. So like we're going to be busting our tails doing all this work, right? But our profit margin is going to be going down the more we bust our butt, right? So we want to aim for about right here. And that's what the cost basis analysis does. And I think that is the most interesting thing about this particular example. And it's also something that wasn't really talked about in this example. Anyways, that does conclude today's lectures on Chapter 1, Section 6.